it's about time we go over the solution to weekly math challenge number 4. Amy has a 2017 page book, which is pretty long, with pages numbered from 1 to 2017. How many page numbers contain both at least 1 1 and at least 1 9? So the examples, 91 contains 1 1 and 1 9, 1921 contains at least 1 1, at least 1 9, 191 contains at least 1 1, at least 1 9. So how many page numbers have such property? And that's an interesting question, and I'm going to break it down into 2 digits, 3 digits, and 4 digits. So 2 digits, 3 digits, and 4. Why do we not have to care about 1 digit? Because you have to have at least 1 1 and at least 1 9. So you need at least 2 digits in order to accomplish that. So for 2 digits, it's very easy to count. There's 19 and 91. So there's 2 choices. Let me write the choices in blue. So there's 2 choices for 2 digits. How about 3 digits? So by 3 digits, I'm talking about 100 to 999. And if you try to count this, okay, so there's 109, it has 1 1 and 1 9, 119, 129, 199, 209, 219 I meant, and there's a lot that you have to count, and you may make it through, but if 3 digits take you this long, 4 digits is going to be a really big pain. So we want to figure out a systematic, more mathematical and logical way instead of just blunt counting to figure this question out. So how can you count this? And how I counted it when I made this question was, think about it like this. You need to have at least 1 1 and at least 1 9. So if 3 digit number contains 3 spaces, either the first 2 or last 2, or first and the last one, and reserve those seats for 1 and 9. So you have 3 choices to figure out what's left over. What do I mean by that? When you have 1 and 9, you have 3 choices. You have 3 choices to pick a blank spot. You can either have 1 and 9 here, 1 and 9 here, or 1 and 9 here. So there's 3 ways that blank spots can occur. So, and for each of those spots, you can have another possibility by switching 1 and 9. By switching it, we get twice as many possibilities. So what I'm trying to say is you have six possibilities associated with how you can pick 1 and 9. So 6 choices. And once you pick 1 and 9, you have 10 choices to put whatever you want, all the way from 0 to 9 times 10. But the thing is, what's the flaw in this? You're allowing 0 into it because 190 is obviously a number, but doing it this way also count 019 and 091 as a 3-digit number, which they aren't. So at the end, we are going to have to subtract 2 from whatever we count. But are we done? Is it just 60 minus 2 and are we done? And we are not, because we have overcounted. And the reason we have overcounted, consider a number like 191. You have focused on 1 and 9 and counted once, and you have focused on this 1 and 9 and counted once. So you counted 191 twice in this 60. So you want to subtract 1 for 191 because you're counting it twice. You want to subtract 1 to go back to it. But how many ones do you have to subtract? How many are you double counting in 6 times 10? Well, there's 191. And you can shift this 9 around, 119, 911, and there's symmetric cases with 919, 991, 199 that can be generated by switching 1 and 9. So you actually have to subtract 1 6 times, or you can just subtract 6. So how many possibilities do we have? 60 minus 6 minus 2, or 52. Let me write in blue as I said I was going to. 52. So you have 52 choices for 2 digits. I meant 3 digits. Now let's go on to 4 digits. Or since you're only counting to 2017, we only have to worry about 1000 to 2017. But if you think about it, from 2000 to 2017, you're not going to find anything. So you only want to go from 1000 to 2000. Actually, let's narrow it down to 1999. Or 1999. So this thing is 4 digits, limited case of it. So once we count this and add them up, we should be done. So how can you count this 4 digits twice? And how I'm going to count it? It's 4 digits, and you know the first digit has to be 1 because you're picking between 1000 and 1999. And I'm going to ask you, one of them has, as long as one of these three, at least one of them's 9, we're done. Because once we have 9 in one of those spaces, we have 1 1 and 1 9, so we can stop counting. So we can pick 9. You can either put 9 here, you can either put 9 here or 9 here. So you have 3 choices for number of 9s you can pick. And once you picked 9, you have 10 choices for each of the blanks. So you want to multiply that by 10 times 10. And have we overcounted in this method? Yes, we have. Consider now 1911. Centering on this line, you counted this one. I meant 19. I want you to have 2 9s. So let me write it. 19. Consider 1919. Focusing on this one, you counted this number once. Focusing on this 9, you counted this number another time. So you have double counted this one. So you want to subtract. You want to subtract the number for which you are overcounting. So how many is this occurring? How many has 2 9s? Because when you have 2 9s, you have counted twice in this 3 times 10 times 10. So to have 2 9s, you can pick it using 3 choices, like this, or like this, and you have 10 choices for the remaining number. So it's going to be 3 times 10. And are we done? And we're not, because we gotta consider 1999. What's happening to it? Centering on this line, this 9, you're counting the number 1. Centering on this one, you're counting it another time. Centering on this one, you're counting it 3 times in this. So you have counted 3 times. And over here, centering on these 2 9s, you have counted it once. These 2 9s, you counted twice. Centering on these 2 9s, you counted once. So you have not counted 1999. So you have to add 1 to this. And this thing gets you 271. 271. Let me write it in blue. So our answer is going to be 2 plus 52, which is 54, plus 271, or 320.